Okay, rechecking audio. Live stream's coming back up. Power cord on the internet was pulled again, but the audio sounds okay. So I think we're live again. Sorry about the leave. I'm back. And where was I? Okay, so our build complete without errors. I don't like these. Here. We're just gonna delete it all. To do steal from gas. There we go. At least the build continued, just because the internet's down. Doesn't mean I lost everything. What a pain, though. But now we need to test to make sure that the scheduler staying alive between scenes doesn't cause me any issues. Backtrace scheduler. C manager init is called long after sound is initialized. Sound init sound. $4.59. So what have I done? What is this doing? What is this doing? Scheduler process sounds event. Really? Static initialization and destruction. At scheduler 279. $279 is not a helpful line of code at all. Scheduler CPP 12. Sound 221. Which then blows up here. During static initialization and destruction. Why is the scheduler not statically getting set up correctly? Okay, let's change it then. Let's remove this init. Go to application. We could even what? We could even dynamically allocate some of those buffers instead of having them static. Since their life cycle is over the whole thing, it doesn't really matter. Still fails at the same point. Okay, so scene manager, let's go to scheduler. It's where we call init. Sound. Oh, S underscore. That's true. Sound pool equals new array of sounds. Thank you. We'll fiddle with this just a little bit longer and see if we can get it to run. Otherwise, we'll just roll it back. It's not that big of a deal. Okay. So now the scheduler doesn't go anywhere. Want to see that animation again? Yep, just like I want. Fill things up. Okay, chips, waxed, jacks, laced. F or G? It's G. Grunt. Now, okay, everything works great. One thing I want to see. Oh, what? Backtrace. My playlist, my music library. All right, we're gonna do a couple of more things. Let's go to scheduler. Let's also make this one null. We'll go to init. At least be consistent, right? Doing that, but we're also gonna have a cleanup. Void cleanup. Okay. Then application. Clean up the scheduler. And it's cleanup. Where's our cleanup? Okay. Tidy up and debug. And hopefully we won't have any more problems with the scheduler. Well, the other thing we wanted to do is in scene. I would like to see it between scenes. We'll let this build finish. Made errors? What errors? I didn't see any actual error. Oh, wait. There it is. That's better. No. Okay, now frames per second. Around 2800. There's a small skip, but it's 1600, 1300 frames per second. It's not bad. Hmm. Fight. Plum. Surrender. Exit. Okay, and then quit. RTL, 0 memory. Why? Backface. It's when it's free. Do we need to do a full clean and debug? We're doing this. Clean and debug. I guess. Oops. This is like a full debug, re-embedding all of our assets. And sometimes where it just doesn't make sense for it to crash because of some weird memory thing. It's because you have a fragment of some object file somewhere. Incremental builds, kill. Oh, okay. We're gonna get that cleaned up and built. It takes a couple of minutes. So looking at our to-do. Postmortem. Embed binary data needs better compression into strings. I do tend to agree with that. It might speed up our compile time a teeny bit, but I don't know if it'll have a meaningful impact. And Steam integration. Like this is the big ticket item. These are like the big this is the big ticket item and a website. Advertising is a little bit tricky. It's not something I ever wanted to know about. Okay. QOI. That's one I've wanted to do for a very long time. Now, there is an example implementation of QOI on the implementer's GitHub. And I kind of want to implement it for myself so I understand what's going on. So for compression, I don't know about audio compression. I suppose one way you could do it is take an FFT and anything that's close to 0, you just leave out. Like if there's blocks of zeros, you can say here's a start range, here's an end range, and here's the data. Here's a start and end range, here's the data. And anything that's not in there is just considered 0. That would shrink your storage time. To implement it, you'd say, how big is my sound file? Pre-initialize the array. 0 fill it, and then go through each range where you have real FFT data. Plug it in, and then run the FFT again. Return to the time domain. You can even set your threshold for what you consider a 0. Which I don't even know if that would work that well. You can do it per block of audio. So you chop a sound into 5, 10, 15-second chunks and compress each chunk as best you can. I don't know. Like I said, there's a lot of things I don't know about some of this stuff. Just spitballing. To do single channel FFT each 10-second chunk. Filter 0 or something near to a sparse array. Basically, the more you know about your data, the better you can optimize it. So trying to compress sound using text compression methods is terrible. Same with like video, they don't behave like text at all. That's just full, cleaned, and filled. It seems to happen during the exit. Everything else seems to be working fine. Oh. Well, now wait patiently. Playlist. What is happening in our playlist that's causing this? Source, playlist. Line 32. Entries is null by default. Where is playlist? It's memory wise. Music player. This should make no difference. It should compile the basically the same thing. I'm not even really sure why this syntax exists. I'm not sure what it really buys you. So who's screwing with my music player? Music library 11. Oh. I see, maybe. This is also one of those namespace things. We can make this. Yeah, this doesn't matter. Okay. New playlist. Rock gets 3. Playlist equals the address. Okay, let me think this through here. Search for playlist equals the address of a thing. Okay. 3521. 2-1. Christmas and then Halloween. Halloween needed 3. Then every one of these is a null pointer. Okay, that's a nit. Now we need to clean up. Application. Music. Library init. Cleanup. Okay. Okay, application. We're unhappy with music library cleanup. That's because we didn't put it in here. All right, let's wait a minute. We'll rebuild, and hopefully that fixes that issue. Pointers. Permission denied. Will not be denied. I will build and execute this thing. Okay. And quit. Exited normally. Perfect. All right. Scene. So this all works much better, I think. All right, scheduler is now a namespace. Found an issue with playlist being cleaned up by music library. So we fixed that at the same time. I kind of want to know, well, that's not really a valid measure anyways. Okay. That's basically it. Init status. Computer's lagging a little bit. Or Emacs or somebody. Wow. Oh. No. Oh, that's a huge file. Okay, well, git add everything. Scheduler is now a namespace. Fixed music library with a cleanup. Probably should describe better in the journal what the problem was. The automatic static cleanup of music library is no good. Created a cleanup function and call it from application. Wow, my son. There we go. Journal. We got everything done. We got everything done we wanted to today, which is great. Add a doodad. $230. Okay. Doodads. We have there just aren't that many places to put things. Our game scene is pretty compact, not compact, it's pretty space efficient right now. So I don't know what I want to do about that. A paper airplane flying across the screen could be distracting, but I'm generally okay with it. There's room here. There's some room here, although the error banner kind of takes up a bit of space. We could put a small chalk drawing here, a random chalk drawing. There's some dead space here, but like, does this all become too busy? If we pack things into these spaces? I'm okay with the paper airplane. The globe would kind of have to sit right here, which would not be very big. Click it, make it spin. Maybe like an apple. We could put an apple there, like this. Just not that much room. Hmm. Yeah, I don't know what I want to do about that. What do I want to do? Ooh. What do we want to do about it? Make sure replay is still working. Oh, then we waited forever. So quad speed while we think about doodads. I think a chalk drawing makes sense. We could even do some little sprite drawings. That's not the worst. Little sprite drawing crawling across the board would be kind of cute, maybe. There's not much space here to play with. Like, it is dead space, but it just doesn't, it's not usable. Hmm. Oh, let me think what to do. What to do. Even in a game, let's see here. 9 sounds max. Yeah, it looks like there's about 9 sounds maximum. Okay. Doodads. Most I can think of like things to do with chalk drawings. A globe. JTL sprite chalk drawing for every day of the year. You do realize that's more art for you, right? That's No, I'm joking. Some of it I can definitely do myself. But what to do with it? what to do with it. Okay, so let's see here. Let's just spitball some ideas here. Ball, click and drag to lift, and release to drop. Mini physics found in chalkboard. So you can drag it to the top of the chalkboard and drop it. If you have momentum when you release the ball, it would fall using basic bounce physics off the edges of the chalkboard. That could be kind of fun to play with. It would mostly be out of the way during normal play. What else? Dirt, click, plant, dirt. Clicking causes plant to sprout and grow. Like I'm thinking like school things, like maybe a dinosaur. Click to roar. So it wouldn't do much most of the time. What about a chalk drawing of a spider crawling around? Click to smash. Like it would all be chalk. A drawing of a spider crawling up your board. All positions are found inside the chalkboard. Are clamped. So the spider would crawl around randomly on the blackboard until you smash it. Maybe that would be a good one for Halloween. Christmas tree lights on off. On click. I think right now paper plane is probably the easiest one to do. We could fake a spinning world globe until I can do some. Let's start with paper airplane. It's not dynamic. All it changes is the position and its heading. The Christmas tree with the lights on and off might be better on top of the bookshelf. On bookshelf. Lights go on and off. This is more of a, this lets more of the chalk drawing ideas, I guess. The spinning world globe could go chalk or on bookshelf. Couple of options there. I like the spider being chalk and being smashed. That could be fun. Dinosaur. Trying to think what else we could do to fill up space that wouldn't become too cluttered. Hey, let's see here. Brian, how are you doing? Crawling to, let's see, your sprite chalk drawing for every inchworm crawling to or from an apple. Okay, yeah. So let's see here. Maybe inchworm. Crawling to apple on bookshelf. Okay, let's see here. Brian JDC. Idea: make a category of constants that can be modified at runtime, making a list of all instructions, address, using it as an immediate overriding the value where the user changes it. Writing the code by integration, the constants for strength reduction, and const folding. I am well. You know, there's so much to say here. So in the first place, we've already got like mini virtual machines running inside of our system that kind of work almost the way you talked about, like replay. We store the replay And basically, as the user interacts, it stores a bunch of constants into an array. Then we save it out and reload it. Those constants are then run against a virtual machine that causes the game events to happen. So you're actually not far off of some of the weird things we do. Like here are opcodes, and then like in validation, like here are, let's see here, where is it? Here we go. We're getting the args per opcode. Like we have a little virtual machine running in here. So you're not far off. We actually do some weird things in this game. Overwriting the value when the user changes it. Yes. Writing the code by integration, the constants for strength reduction, const folding. Oh, yeah. Why using a VM? Well, it's not a VM. We wrote a mini VM, like our own virtual machine. Like there's this replay object maintains its own state, and it basically reads through the tape like it's a Turing machine, except that in the case of things like playback, there's no branching, right? It's just a recording that we play back. But because of the way we wrote it, we could do weird things like branching, where you could potentially in the future say, do our playback. Oh, pause here. I want to play it from this point on, and then you can go back to the starting point. Why using VM? Do you have to de-optimize? No, this is actually quite optimal. Like I said, right now the VM doesn't do much. It literally plays forward. And by virtual machine, I just make a state machine that reads opcodes out of a binary array. I don't know of a much more efficient way to store a replay. How do you replay and have game speed be the same? Do you frame limit? I don't know. So when you're recording the replay, the game itself is in charge of time. When you're playing back the replay is in charge of time and drives the clock inside the game state. So inside the game, if you're in playback mode, the game clock gets its time from replay. But the other way around when you're playing. No, we don't frame limit. We do allow some variation from the measured time. So for example, if we go into turn on vsync, now it's on, so we should be only running 50 frames per second. Yeah, we're hard locked at 60 FPS. Then when we run, it will get a different end time. Like it has 108.996 seconds here. That will not be the final end time of the game because of the difference in frame rate, and we just allow that. If you turn on frame rate, vsync or not, I'm not that worried about it. And if you record your playback with vsync on, then playback, yeah, so we're 109. Because we were running vsync, it went that one extra frame before it was past the end time here. But we were playing with the idea of a music player that was more like a Turing machine. It would actually have branching and looping, because then we could write songs by fragments and have it like point to each other and do key changes without doing much. You record time associated with events? Yeah. So let's see here. In-game scene, log. Let's just take that out. Whoops. We can log the replay if we're in playback mode. So let's do a quick little build. You can see what our instruction code looks like. Again, there's no branching, but the way we built it, we could add branching later if we want to. It's also very compact on disk because everything we store is binary. There's almost no data overhead at all. So let's do the quick build. We can show you what one of these looks like. So if we run it, we load up our latest replay. So here it is. Instruction 0 selects a seeded word, waits for a quarter second, and then when we say resume, that means basically it means play the next instruction from here, even though time hasn't advanced. We typed A twice, deleted the extra letter, then we waited for, so these are all timestamped events. And the opcode, and then whatever arguments go with it. So let's see here. Reject remaining or accept remaining letters in a word. So it's word 14, etc., etc. Submit guess. Juice. Then we select a new word. Wait for some amount of time. And so this wait means don't run the game timer because it doesn't count towards your execution time. Resume, and then they surrendered right away. So there you go. That's kind of the simpler thing we did. I don't understand if it's native x86 or not. Nope. It's our own. Basically, for a replay, all you need is what event happened at what time and in what order. And so we just store a binary array full of these instructions. And then we save that out, we load it back in, and we execute it by the replay maintaining its own state of the game. Yeah. Yeah, no, when I say virtual machine, I don't mean like we're using a real virtual machine. I mean, we conceptualize this teeny system within our game as a virtual machine, or you can call it a state machine, right? Kind of the same thing in this case. Yeah, we don't even have that many opcodes right now, like replay. Let's hit replay.h. So some of these opcodes happen during gameplay and some happen during playback. So freeze and thaw mean the user has done an action that doesn't affect their total running time. So stop marching time and then resume time, at which point we can then write, when we get the thaw command from the game, when we record the playback, we instead write a wait. We don't write these down. And then resume says, go ahead, game, and restart your clock. Things like that. So enter letter, delete letter. So just basically use your inputs. There's our opcodes. There's 21 of them. Not very many. And again, when you're playing the game, you select a random word, which feeds into, when we're recording, that's turned into selecting a seeded word. So I know what the seed is. I don't want to tell you what the word is. I don't want it stored anywhere. But here's the seed to randomly generate this word, the word that was generated here. But yeah, surrender, clear deductions. Yep. So very simple system. Like I said, though, we can add things like push states and resume, so somebody can play from a partial replay. You can replay up to some point and then say, oh, wait a minute, from here I want to practice. I think there's a better way to deduce that word, blah, blah, blah. We don't have that yet, but it's possible. Yeah, thanks. So what brings you here this fine day, Brian? We're building a game with no game engine, minimal dependencies. I don't know if you want the full spiel or not. Up to you. But minimal dependencies, so when we run the game, we print it out every time. Where is it? Oh, here we are. That's it. That's our list dependency list. Glue, GLFW, they kind of come together. Then we use OpenGL 3.3, nothing, no extensions, nothing fancier, keeping it minimal. GL Math, which I want to get rid of. Free type for font rendering, which I want to get rid of. Port audio, I'm perfectly satisfied with. Our entire executable is standalone, so all of our assets are embedded within the executable itself. We are completely statically linked. My executable should run anywhere with no external DLLs. So, just trying to keep it small, simple, and have some fun and do some learning while we're at it. I do have time speed control. Okay, so yeah, you want to see that, we can do that. So if we reset, just to make sure we're zeroed out, you can run at quad speed. They do have to be integer values because of the way that I'm morphing the sounds. And by integer, it can also be divided by integer. So if you want to watch somebody play at slow-mo, you sure can. Boom. So yeah, I think it's kind of fun. If you want to see exactly what people were clicking on in what order, quarter speed is far superior. If you want to skip over the parts where they're thinking, you can run it at quad speed. So yeah. Boom. So what are you interested in? What are your interests? I like software development. I like learning things at lower and lower levels. I've slowly been peeling things back. I'm not down to bare metal assembly yet, but we are working our way towards that in our compilers on Friday. We're nowhere near it, but like that is one thing I do want to do is we're going to emit, x86, 64 Intel assembly. I've got the manuals downloaded somewhere, so that'll be fun. I don't have an ARM machine to run against, so it'll probably stay Intel for a while. And that's all way down the line. Like we do the game development Monday through Thursday, then compilers is like my break day, my palette cleanser. So it's not a ton of progress being made there. One day a week, it really isn't that much. But it is kind of fun. It's something else I'm interested in. And thanks for the follow. Appreciate it. So yeah, I'm not down to the point of learning bare metal assembly. I've used fake assemblies in my compiler class. I have like I said, I've looked over the Intel x86 64 manual, but I haven't implemented anything with it. I want to get further down the compiler road before I do. The whole compiler thing is like this. It's really bad. Don't do it this way. We're basically implementing everything I can think of, every which way, broken up by pound defines, so I can build all kinds of weird combinations of things inside my tokenizer generator, for example. But that's all besides the point. It's gonna take us a while to get there. But yeah, welcome aboard. Welcome aboard. Yeah, I'm just trying to get lower and lower level over the years. I used to be annoyed about the lower levels in my youth, but the older I get, the more I realize that the more you understand of the underlying structures and processes of a computer and what it's actually doing with your actual code, the more interesting it gets. So, are you experienced with bare metal assembly, or is it just something you're interested to look into? Have you studied type theory? No, well, studied. I've done some light reading. I would say it doesn't affect me much, therefore it hasn't stuck in my brain. I know. Yeah, no, not to any degree that I would call serious study. Done a little reading. No, I couldn't say I've studied it in the sense of I've learned and mastered the material. But I do know what a monad is. I don't know if that counts. I do assembly in QEMU, mostly doing research at the moment. Oh, really? Okay. Research like at a university or college or something? Or independent? QEMU, I've heard of that, but it wasn't on my list of things to consider. Run operating systems for any machine on any supported architecture. Linux, BSD. Okay, QEMU. Bookmarked for future reading. Indie. Okay, yeah. Cool. I love looking at other people's projects to see what they're doing. It gives me more ideas, teaches me things I've never thought of. So what's your research trying to achieve? Is it self-learning? Are you trying out new ideas? So, for example, my compiler series, so far we have done nothing new or innovative, but we're getting close to the point where I've had some, I think, unique ideas to experiment with. We're going to do some things with PDFAs that I don't think I've seen anywhere else, and abuse the heck out of DFA in a way that I don't think anybody else has tried. I don't know if they'll be faster, well, the one has nothing to do with speed. But I do have an idea for one's speed related, one is just the expressiveness. What can I express in my tokenizer generator, which I know works. So, because I've prototyped it in another project back before I started streaming. Research with Kimu. Interesting. Whole system emulation, user mode emulation, virtualization. Okay. Replacing all code with constants and turning code into declarative form from the binary. Okay, I mean, I have to think about that for a minute. Like, replacing all code with constants and turning code into declarative from the binary. Don't you still need a small runtime portion to interpret the constants? At which point, aren't you just then building a virtual machine? I'm trying to think how those constants, unless you're binary packing your own executable. So you're still emitting, x86-64 binary, but you're doing it yourself instead of going through a compiler and linker. I guess I'm not 100% sure what's being done. Either you're writing a virtual machine or you're emitting your own handmade native. Okay, yes, exactly. Handmade native. That is one of the ideas we want to get down to. So in the compiler series, and we're nowhere close to this, but I want to first, this is like my show everything you could do. We're going to start probably with the transpile to C, then maybe we'll target some virtual machine, I don't know, JVM, or pick a virtual machine, target that. Then target maybe LLVM or an x86-64, maybe like a NASM, FASM, or WASM. I don't know which one. Assembly language. But ultimately, I think a handmade native executable would be a great place to end, because that removes more dependencies from the chain. Which is, yeah, so that's cool. You want to turn your own handmade native. Do you have like a blog or anything like that? What's your sleep function? Sleep. In which context? Sorry, in the replay? This wait? So inside the game event loop, the replay has an update. And all it does is measure the elapsed time. Let's see. And if we hit wait, it just says, here's how much time we need to wait before the next event. And then up here, it literally just scans through until the next timestamp is greater than our elapsed time. So yeah, we're just adding an offset. And so it does this as long as, let's see here, where's the break? Yeah, so there's no sleep function here. The loop continues to run even when we're waiting. Yeah, just do native directly. Yeah, I think that would be cool. And in fact, not on this account, but I have RDTSC or query performance counter. Right now I'm just using GLFW's time management. So time, we're just using GLFW, and which gets the highest resolution native monotonically increasing clock, I believe. Which in this case I don't know which one it is. And then we only update time once per frame. So even between frames, where's the update? Update. Update only happens once per frame. So these times don't change until the next frame. I don't blog, only do it when I'm done so I don't get distracted. Yeah, that's not a bad way to go. But that is very cool. So you're targeting Linux then, you said? Okay. Yeah, I found some links on the structure of the Windows binary executable output, and it's the .pe portable executable, which is a joke today. My time is float. Double. We're using doubles. So when we update glfw get time, I think that's double. It does return double, yeah. So no, we get doubles. Yeah, no. Float starts running out of integers at about 16 million, so although that is a lot of seconds, 16 million seconds is quite a bit of time to measure, so maybe we would have been fine with floats, but the loss of precision is so fast in float once you get out past 1 second. Yeah, I was looking at the Windows executable file format, and it's not well documented, but you can find it. They don't want you to do it. They want you to use their Windows Visual Studio to build everything. Makes me sad. Have you tried maxing out time speed? I wonder how you make it work if it's CPU limited. So the time scale, I've not tried to max it out. I basically went to quad speed, which is about as fast as I wanted to watch. Yeah. Yep. So scale. That's how we do the scaled time in the playback. When we update at the top of the frame, we take our real time. So let's see, we get our timestamp, subtract it from the last time, and we need to track real time versus scaled time separately. Then our DT is scaled, and our last time is just incremented by DT instead of by the real delta. That's it. We can still access real time, or we can access scaled time. Oops. It seemed like the easiest way to get scaling time. So all of our animations and things, let's see here. We can tell it whether to use scaled or real time. So it can either scale with time or not. Same with sound playback. By default, it's using the scaled time. Let's see here. If we're using scaled time, we use that one. Yep. Sound, animations, all that stuff. You can use either one. If you disable animations, do you ever get CPU limited when reading events and replaying, let's say 100 times? I have not done that. So let's go to settings, turn animations off. Like we still have blocks in to say wait for the sounds to finish playing, but nothing's going to animate the same way. So if we play, this is cheat code, so I don't have to type in all the words every time I want to test something. That did not, yeah. So if we leave, playback, so we allow it to go up to 4 speed, and it has no problem. But I've not unlimited it from 4. Let's see. Playback controls. Do I have constants declared? course not. So we are right now mostly CPU draw call blocked. Where is it? Speed up, slow down. There it is. Yeah, so we're hard limiting it here. Do I have to make any changes here? Yeah, we're kind of hard coding it, which is not great. Okay, so if we want to unblock it, let's go max time scale 16. We might as well do this the right way, right? Main time scale 0.25. We're not going to go slower. That's boring to watch. But we will replace it with a constant min time scale. Then down here, we'll assume we're correct for now. We'll just hard code this in here. Otherwise, up to 0.0f and give it the scale. Oh, we've already got it. Okay. Let's try it. See what happens. Let's even get up to 16. Have you done CPU rendering before? I have. Well, yes and no, I guess. Rendered to a texture, then blid it onto the screen. So I don't know if that's quite the same thing as what you're talking about. I know there are some very crazy fancy things you can do, but I have rendered to a texture and then blitted that to the screen. All right, so let's get a longer play. See. Wow, not a lot of clues here. Oh wait, nope. Undo, clear everything. We do that. We do that. We do that. We take C. L goes away. That all is in. No M. So it's punch. Oh, which we already knew. Okay. Autofill for some reason is not working correctly. It should stop one word short. Whatever. Let's go back to the replay. So hopefully we can get all the way to 16x. Well, there you go. It still worked at 16. So you're saying go to 100. These those buttons won't repeat. Okay, so let's do this. Init element. We're going to do time set scale 100 update runtime level. We'll just hard code it. Why not? Yeah, I'm gonna need a longer playthrough though. So let's go to like a sprint mode. We can watch the clock. Mouse clicks create game-specific events, so you don't need to record coordinates. That is correct. Everything is laid out very carefully, and I don't need to know the actual location. Let's go to sprint mode. So this one, instead of counting up your total guesses, it counts how long it took you. So we're going to fill this up with guesses. Okay. I'm not sure why it's terminating. Why is it losing? It should be stopping one short. My cheater's broken. All right, what if we do it? Oh, kill it. Erupt. That's a good word. Let's try this one more time. Bunch of random words. And then it's failing one early. Why is it doing one early? This should not come up yet. All right, fine. We'll just play word. We'll do it quick. Prime lunch. Toads. Demon mace. Rhino. Outlines. Ding ding. Match. Which means we get laced. No N, therefore I and S are in. BD logs. Jacks. Waxed. Oh goodness. So F or G. So lives, files. What? Oh, well, whatever, we can cheat. Veils, there we go. And then we'll fill it up and lose, doesn't matter. That should be long enough to run it at 100 times, right? We leave. Latest playback. That's not 100. Oh, there it is. Now it's 100. Ready? It dies. My scheduler can't keep up. I don't have enough resources. And by that I mean we use a static pool of animations and action sequences to play through all the actions. And in this case, the action sequences aren't completing fast enough before the scheduler asks for a new one. So then the question becomes, what is our limit? Let's go to gameplay. Game. Let's put these back in. We will try real quick to see if 50 times works on that same replay. Because right now we're draw call limited, basically. All of our frames per second is limited by the number of draw calls. We're not doing that much processing in the background for anything. It's a very simple game, which we did on purpose. I can conceptualize much more complex things. So there's our frames per second. We got... Oh, that's probably because of scaled time. So this is actually useless. Okay, never mind. So let's go 50x. Oh. So once again, scheduler failed to provide enough resources. Maybe 25x. Ooh, that was close. Almost made it. So maybe 12.5 then. So it works at 12.5. Otherwise, I end up in resource issues. Now, can you explain the purpose of the scheduler? Do you have arenas? Yes, exactly. So if we go to yield scheduler, why don't we do this? Since we're beating up the system. 10, 24, 16. We get away with 64 sounds. So we just increased the size of our arenas by a good amount. Can you explain the purpose of the scheduler? Yeah. So the scheduler maintains the life cycle of different resources that are just commonly used in all scenes. While that's building. Oh, we might have to do it more. Yeah, so we have animations. Those do the time-based thing. So in the update loop, it says, what's our time? How long is our duration? Compute a t between 0 and 1 based on the duration. And then we can also parameterize it. So that's where we get those bouncing animations or like a quad in out instead of a linear interpolation. So we can apply a parameterized shape to our things. Action sequence is like change this value, then start this animation, then play this sound, then wait for these things to finish, then do this other cleanup thing, right? Clear a flag. Then a bunch of sounds. So what I'm going to do is I'm going to do a mini clean and build circular buffers with masking the size. Nope, they're just linear arrays. That's it. We walk through saying, are you available? Are you available? Are you available? You're available. Mark you as queued. Return that, and then it's no longer considered until it completes itself. So it's just a linear buffer. That's it. We haven't seen any performance issues that would require us to go to a circular buffer, although that would be more efficient than linearly scanning through the array every time. It's not that I don't know how. It's I'm kind of at the point in my life where I don't want to add complication until I need it. I was listening to one guy talk. He was like, back in, I was fresh out of college, and there was this game, and I looked at it, and written all by those old grognards. And he's like, well, you should use a dictionary here to hash map lookup. It would be more efficient because all they had was an array, and they just linearly walked through it every time they were looking things up. And so he put one in, and it was slower than the array walk, right? So sometimes you just start stupid. You only get complicated when it's necessary. Okay, so we went 25. We went 12.5. Let's see if 25. That worked. Okay, so let's reset. Reset? Uh-oh. Alright, we'll come back in. So that worked at 25x. Let's try 50x. Nice, nice. I don't know if we can get 100x. 100x. Ready? Here we go. There you go. That was 66 seconds worth of play in 0.7 seconds. I would do a cursor that gets ended. Yeah, the circular buffer could definitely be improved. Like, here, actually, we could just add a note while we're here. My to-do list. We have all these tasks to do before we can release. Here's my list of discarded and delayed tasks, right? So if I go to pool, this is now 3 pools. Circular buffer with and like, it's not that I don't know how to do it. I just haven't really. I don't prioritize it. That's like a between projects. How much bigger did you have to make the buffers? I made them 4 times bigger. I don't know if I needed to. I'm curious, actually. How much? What size could we get away with and still go 100x? In our scheduler, so we quadded them. So if we go 512 and 32 for sounds. We'll try that. We'll play around. These are things I wanted to explore, like between projects when I was implementing a more generic pool type of implementation. But we can play around today. We've got good progress done today. This is when having dynamic constants would be useful. Yeah. Well, and that's one of the things about these pools. Like, I can rewrite them to be whatever I want since I'm not using somebody's library. I can resize the pools if I want to on scene load up or whatever. Dynamic constants. Kind of a contradiction in terms, a bit of an oxymoron. Unless you're doing like code hot reloading. Okay, so let's go back into replay. Let's just go all the way for 100%. Ready, go. Oh, we only needed to double our size, I guess. Reset not working. Good heavens. Although, that could be because of our time scale. Let's see here. I can't change the time scale. Reset. Yeah, our buttons aren't working once we hit the end. So that needs to go in the bug list. Well, for one, cheat failing or failing when it's losing when one word short of full. Why? Replay won't reset or navigate by word once lost. So those are two bugs you gotta fix. Oh, let's see here. Having a check to see if you're near the end, then recompile to overwrite the sizes. Or have the user change them in the game. You know, you have to make the page unwritable, then have a pointer to a symbol entry that makes a view on the first instruction using the constant. If you modify the value at the view, you page fault, then you ask the view to get the symbol, overwrite the whole list of instructions. That sounds complicated. That sounds like the kind of thing that's very brain twisted. It's like writing your compiler inside of its own compiler. You can do it, but by the time you've done with all the layers of what happens when, it gets very hard to conceptualize inside of a brain. Interesting. Actually, so I have a language feature I've dreamed up, which involves self-modifying code. It's another one of those ideas where it's like, I think it's a cool idea, but I don't know if it would have any actual performance improvement benefits. Because once you're doing self-modifying code, you have problems where the CPU pipeline gets broken, right? Because it preloads as much as it can, and then you modify a value in your program memory, and that might just not have the benefits you need after the CPU is flushed and refilled. But I think the concept is a good one. I would just have to implement and measure it. For flow control, 4 flow control ideas I have about self-modifying code. Can you repeat? I was like, yeah, sure. So I have this concept for self-modifying code, which, yeah. So I have this idea for self-modifying code where there's a branching construct in your language, which I've already dreamed up and named and everything. and I've implemented it on a virtual machine, like a really bad virtual machine. I just wanted a proof of concept, so it doesn't count. But basically, the first time through this construct, you would execute certain amounts of code, but then it would modify the code just before it to say skip over this block, right? Or vice versa. The first time through a block of code, it gets a jump, which goes over a block of code, and at the end, after it does the jump, it modifies the code that says where that jump is, make it a no-op, so that I'll then walk through the block of code the next time I go through this code. And that sounds cool, and you can do some cool flow control things that might be very fast. But I don't know if it'll be any faster because of CPU instruction caching. Once you modify the program memory itself, your CPU has to flush, potentially, and reload the instruction memory. So it's one of those ideas that, like, it sounds good, but I don't know if it'll be any faster. Does that make sense? So what's the goal of the no-ops? Okay, let's see if I can... Let's get a good old scratch buffer up here. So let's say that you have instructions, blah, blah, blah. You have a no-op, and then you have a block of code. And at the end, so let's see here, this is instruction, 42. It'll say set 42 to, let's say this is instruction 51, right? To jump to 52. So the first time through the code, you're doing things, you hit this no-op, it doesn't matter, you enter this block, and when it hits 51, it says this instruction now becomes jump to 52. So this block of code only executes one time with no branching, and you don't have to check ever again for the branching. Does that make sense? And you can also do the vice versa, where you might have some code, 42 is jump to 52, ... Then at 52, let's see, I guess it would jump to 51. 51 would say set 42 to a no-op. You could have 50 be a jump to 52 if you cared. Like, I mean, maybe that's unnecessary. But you'd run some code, you'd say this, you'd say skip over this block, but as soon as I've skipped over this block, as soon as I've skipped over this block once, I say replace the jump with a no-op, so I always then execute this block afterwards. Does that make sense? Instruction 50 might be jump to 52. I don't know if that would be necessary at all. Jumps have an immediate part. That's the dynamic constant trait. Let's see here. What's the goal of the noise? I wonder if you've heard of Synthesis OS. I have not. It sounds like your idea? Okay, well, I shall Google it. If I'm... Oh, not pin. Oh, yeah. Unpin. There we go. Trying to copy text out. Synthesis OS. Taking a look. Okay. Jumps have an immediate part. That's the dynamic constant trick. You could just overwrite the bytes of the jump. You wouldn't have to do anything, I think. Yeah, and that's possible too, maybe. It would depend a little bit on the features of your assembly language, and what's available. You can do relative jumps, absolute jumps, or yeah, like you said, you can just say jump to the next instruction. As long as you don't care if you can't go through it again. If the single path, I mean. Yeah, well, I mean, the point is, like, I end up in this situation all the time where I have bool first equals true, then for, whatever. And I say, it's somewhere in here, if first equals false, do some things, right? This is a pattern I run into all the time. But it causes branching, and I have to have a Boolean for each one, and blah, 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 right? Or also, if not first, right? I mean, I've used both of those patterns a million times. This would make it non-branching, no additional memory. You know that next 64, no problem. Yeah, no, I know you can do it. I don't know if it's faster than using the conditionals and the booleans. There's a cost to these booleans and these conditionals, which I can remove with jumps and go-tos and self-modifying code. Fine. But I don't know if the CPU cache for the instructions being messed with is worth it. That's what I haven't measured. Yeah, I've conceptualized it, I've prototyped it in a fake thing, but I haven't measured it against real performance. So yeah, who has time to support all their hobbies and interests and questions? I don't know. What were we doing? 100x? Yeah, 100x was fine. And all we had to do was double our arena pool sizes. So let's go and do all that work now. Where was I? The scheduler. 256. 256. We've not needed more than 16 sounds ever. And then we were in playback controls. We had hard coded that. And this now goes to 4. Down here, I do want to check against invalid values, so we'll put that back in. Anyways, yeah, fun little sidetrack. You'll have to get the cache from RAM instead of the iCache, yeah. If you run the same code and don't change it again, your CPU will know it can skip it, even if you don't self-modify it. It costs you 1 cycle, according to Agner Fog tables on most CPUs. 1 cycle for predicted jump. Yeah. So if they can do a predicted jump that's very good prediction, I don't know if self-modifying code saves much. When did that happen? Playlist owned error. Okay. For unconditional or conditional predicted, both are 1 cycle. Okay, okay. Oh, come back, come back. So in theory, our playback should be bound to 1 to 4 again. Yeah. The banner's not going away. So maybe that's the problem in replay. Where's our to-do list? Maybe related to banner not going away. Okay. Blah, blah, blah. Cool. That was kind of a fun little diversion. If you only go through the loop once and you keep the answer forever, I think you should not self-modify. We see that's the trick. There's more to it. There are details that involve undoing what you did, but that would only happen once per loop. Yeah. So at the top of your, there'd be a section that would set all the initial states, and then a chunk at the bottom that modifies the code. So every time you enter that area of code, those get reset. So once per loop, you reset everything. Once per loop, you update everything. And then from there on, it's completely branchless. So it's only the first iteration of the loop has potentially a significant cost, but every loop after that should be screaming fast. Yeah, the answer would not be kept forever. Oh, what was I doing? What was I doing? Oh, we did all this. Oh, we were thinking about doodads. Okay. Let's bring those bugs down below. I don't feel like dealing with those today. Oh, just a moment. Let me go talk to my children about being quiet next to my door. Okay, I'm back. Okay, so a paper airplane randomly flying across the scene. I guess I better go dig up the paper airplane image. We just need one to prototype against, so let me take a look at this one. Oh, interesting. Free with trial. Gosh darn it. All I want is a picture of a paper airplane. One that isn't from stock photos. My gosh. They want me to like sign up and be a member and stuff. We could generate our own paper airplane image. I kind of don't want to. Let's see here. Dun. If you go through the loop once, yeah. If the variable that is compared is not changed, conditional and unconditional will be identical. I don't think any situation where self-modify would be faster. Maybe I'm missing info on the problem. The only thing we should care about is having predictability. Yeah. Yeah, and that's the part I don't know is it even worth trying it out? I think you would get some gains in some parts, but I'm not sure if it offsets the losses that you'd get from that instruction cache miss. Maybe this image. All I need is a small placeholder. I'm going to save that to yield desktop. Airplane. Your branch history could leave cache if it's been too long, so self-modifying could be better as long. Just be careful to replace it back to the original if it will change. Yep. Okay. Well, it sounds like there might be cases where it would work. I don't know how I would communicate. Like, there are parts of it I know how to communicate to the developer, but other parts of it I'm not sure. And for example, if it is if the branch prediction cache, branch history cache, goes out and comes in, I don't know where I would be able to tell the user this is a good case for this or not. Very interesting. Yeah, it's an interesting problem. And like I said, I'm not delved deeply enough into the lowest level of stuff to really have an intuition for what it will do. Where are we at? 340? 340. Okay, well, let's get this going here real quick. Let's open an airplane in GIMP, then we'll share GIMP. Open with. There we go. We're gonna get a small paper airplane going. GIMP takes forever. Okay, now I can share GIMP. GIMP. Where is it? There it is. All right. Color to alpha. Color. Okay. Where's my eraser? There, an airplane. Now crop it. Ideally to a power of 2 or something close to it. What do we got? Width of 256. Perfect. $256. That looks about centered. I said crop. Come on. Oh, wow. All right, I forgot what I was trying to crop. Let's put some guides in. Oh, that crop. No, I didn't crop the layer. Oh, I did crop the layer. Oh, okay, well, image to layer size. Where did that go? Fit canvas to layers. There we go. All right, export. We're going to put this in our asset directory. Images, airplane, .png. That should be it. We don't need GIMP anymore. Let's see here. My idea about dynamic direct calls and jumps is to have the constants overwrite the destination to switch to functions that have optimizations for special cases like scalar unrolled, SIMD unrolled. For granularities 1, 4, 16, 64. Yeah. Yep, granularity, the amount of 32-bit operations to do. Okay. So yeah, so you basically have a function which dispatches to different functions, and you use a constant to determine which function it dispatches to. Overwrite the destination. Yeah, so you're basically setting the jump. Okay. Interesting. then like you said, the user can choose a constant and have that overwrite the behavior. Point of using constants to remove the second indirection. Yeah. Yeah, so you're not doing a switch, you're hard coding the jump or hard coding the go to. So instead of a function call into a switch statement or a branch table, or a jump table, instead overwrite the address of the function itself with the address of a different function. I think, if I'm understanding you right. Okay, images. Oh, we don't have that up. Assets, images, images. Let's go get an airplane. And if I had an airplane, we would do that. Tools bin not slash embed PNGs. While that's working away, we'll modify tidy to let me rebuild the image warehouse, but not the sound warehouse, because that takes forever. Then we go to the code. So something like game scene. So we'll rebuild the image warehouse. Okay. It's a lot of work just to avoid an indirection. Yeah, I mean, and that kind of sounds like my one-time use code, right? I have a particular use case, and it's actually not an insignificant amount of work to get around that one branch. And it may not be worth it at all, so. or my tokenizer generator, right? Like, tokenizers are not rocket science to build, so why am I running a tokenizer generator? Not because it's the right thing to do, but because it's an interesting problem to me. If it's for your own personal research, I mean, who cares how much work it is? It's for fun. I thought about changing the constants automatically, but you would need heuristic, and it doesn't make sense if we just want to save a little bit of performance at runtime. Yeah, the more you have to keep adjusting and guessing, the worse it is. But if a user can load up a binary and say, try it with SIMD4, with SIMD, try it with unrolled. Actually, this sounds like a project that a friend of mine did when he was working on his master's degree, except they were very, very specifically compile time optimizations where it would pick unrolling factors at compile time, and I think it was for large matrix multiplies specifically. But it was all, like I said, compile time optimization, finding unrolling factors and such. VMs do runtime recompilation, have to de-optimize. Oh, yeah. Now, that is also, by the way, going to explode the size of your executable. If every function or if key functions have multiple implementations that you're switching between based on a constant, instead of optimizing at compile time, like, can you profile your machine to find the optimal unrolling SIMD options, etc. at compile time? That would be more efficient because then your code itself is smaller, potentially leading to better spatial locality of your instructions. Just a thought. What am I testing? I'm not testing anything. What am I doing? Sheesh. Okay, so I have an airplane image. Oh, we haven't even opened the header file for that? Okay. I have a texture quad, yes. Where do we want the doodads? We're just going to hard code one in for now and see where we go. Yikes. Texture quad. Airplane. We're just gonna stub it all in here. Game scene.cpp. Wait, it's 4 o'clock. 4 o'clock. Okay. Init game elements. Airplane. Set texture. Image warehouse. Asset. Airplane. It's just embedded. Okay. We're going to do a quick snack run. I have some jalapeno poppers with my name on it, so then we'll make an airplane. So be back in just a minute. Okay, I'm back. Fueled by yerba mate and jalapeno poppers. We're doing cool things. So let's see here. The thing is, if you used compile time, you would still need every version of the function. You wouldn't know which one to use without a comparison each time. You want to synergize with the dynamic constants too to have strength reduction and folding because they have to an impact on the final instructions that need to run. If you compile in advance, you have to turn all your constants into registers. There's a limit on the amount of reg operands. Can't combine those like consts do. Okay, interesting. If someone tried to do the compiled version of my program, his code size would be bigger because he couldn't merge instructions together because he's using registers instead of constants. Dynamic constants have to be recompiled only when you change them. It's good for graphics, GFX or game settings. Turning all arrays into constants with compile time, safety, and adaptive. Okay. Well, Daddy? Clearly I have not studied enough type theory to understand everything you're saying, but I think I get the gist. Okay. Interesting. I'd be curious to see what kind of performance differences you would get. I have, so while I'm interested in the lower level, like assembly level stuff, I haven't done projects with it to any degree that would mean I have any intuition for its behavior. So I would be very curious to see what you come up with. And I love jalapeno poppers. They're so good. Very tasty. Num. Okay. So our game, we're going to set our airplane texture. Airplane set. We're going to start code some things in here. Renderer. Scale. Let's put it at 100. 100. Width and height. We know what to do here. We do float width, height, image warehouse, get UV size for image warehouse asset airplane into width and height. And we have to scale those as well. So they stay on the screen when we resize the screen. Then we have to render it. And it will be on top of everything else. So it renders last. It's not going to do anything yet. Let's just get it on the screen. Synthesis OS, from what I've read, does something similar, but for system calls, and it's more focused on kernel performance instead of general performance. They don't use as many tricks. There are a lot of tricks, and I don't know hardly any of them. Synthesis OS, yeah. I got that bookmark now to do some reading up on. Raw VM does the same thing as what I said, I think, but to de-optimize because they're just optimistic. Okay. Another one to read up on. Raw VM. Oh, it's a JDK, huh? I'm sorry. I see Java, and I'm just like, nope, not interested. All right, game scene. Oh. Oh, not asset. Oh, okay. Yeah, what was I thinking? This is the wrong call. Image warehouse, get width. It's not a UV, it's an actual image. So we don't have to compute the UV size from our UV coordinates. Too busy talking, not enough time thinking. Get width, get height. H-E-I-G-H-T, so close. Do you know what refined independent types are? Nope. Or if I did, I don't anymore. Like I said, I've done a little reading, but it never really affected me in a way that made it stick. I'm ready to learn if there's a succinct, easy way to summarize those, or I guess I could just look them up. You know, that's also possible. Find types. Refinement type. A refinement type is a type endowed with a predicate which is assumed to hold for any element of the refined type. Okay, so you can add logical predicates circumscribing the set of values described by the type. Okay. Mostly understand. I would not say grok. Every instruction applied on a register changes his type. Yep. Either start with a singleton, that's the name for a constant, or you have a value between 0 and max. When you have to compare to a constant to know in what range it is, you should look at the WUFS wiki on GitHub. WUFS wiki on GitHub. Is that WUF FM? Oh. Special purpose programming language development. Okay, I see what you're saying. So I shouldn't search for wiki. WUF programming language. Which there's a GitHub for. Ooh, I saw the acronym. What was it? Wrangling untrusted file formats safely. Okay. It's ridiculously fast. Goals and non-goals hermeticity. What does WUF's code look like? Interesting. Directory layout. Calling Go. More or less. Non-C, C++ languages. Python bindings. Status. Okay. Interesting. More reading. In each branch, you know for sure what the type is because the comparison refined it. Okay, that makes sense. So far I'm tracking. That is not an airplane. That is wrong, wrong, wrong. Shame. Shame, shame, shame. So what happened to airplane? Oh, I'll bet airplane is a copy-paste error. We load the right file in. Yikes. Yeah, I probably should do more actual reading on type theory. There's always something else I'd rather do, so. Let me see. I need to rebuild. There we go. Game scene. Make the file still the same. Good. If you write a program in normal C code or whatever, you can look at the history of operations made on a variable, generate the instruction, then apply them to the constant when recompiling. We just changed 4 bytes, though. Generate the instructions, apply them to the constant when recompiling. Right. You would then have to have a very large history potentially if every variable maintains a history. Although it's per scope, so I guess as long as you don't do as long as you don't do global variables, it might not be too bad. I mean, your history is essentially the size of the entire program. Just a handful of instructions, I think, since you picked the smallest common denominator between all callers. There's an airplane. We did not get a good output, but it's fine. This is just prototyped. Okay. Step 2, make it fly across occasionally. So we need an egg timer, airplane launch timer. Then we need a function, void launch airplane. Just make it so it's a searchable thing here. Doodads. Do I have a random number generator in here? I'm pretty sure I do. I do. Okay, good. Set duration. urng.next between oh gosh, let's go between 5 and 10 seconds. Airplane launch timer dot set single shot true. Airplane launch timer dot set callback to this thing where we are going to call launch airplane. Getting scene launch airplane. Part of this is we choose when next to do the thing. But there's some situations where you could need to multiply by 4 or add an offset, and each constant parameter has different little operations like that. Yeah, that makes sense. Maybe we do this in make sure the timer is getting treated correctly. Launch. Next launch in seconds. Airplane launch timer dot duration. Okay. We should see that popping up in the console a couple of times here and there. But the idea of having the whole history of the program being the type of a variable is what's called the Curry-Howard correspondence. If you reflect a program in the types, you get something that's proven to be correct. Propositions as types is the catchphrase. Okay. If you look at code in theorem provers, sometimes it looks like they write the program twice. Select the program in the types. You get something that's proven to be correct. Okay. I think maybe this is where I start losing it with type theory. I don't know that there's a good introduction to it. What are the fundamentals I need to learn? People go pretty quickly to this proves that, and therefore, and it's like, well, but what are the fundamental building blocks I'm even working with? Do you know a good type theory primer. Oh wow, we slipped into Python mode there. Good heavens. Oh, my jalapeno poppers are gone. That's very sad. No more jalapeno poppers till tomorrow. You describe the operations, then you describe what variables can execute the operations, but the types have operations on them, so they meet. Okay. I don't know good sources. Okay. Well, it was worth a try. In real life, I've not run across too many type theorists who could point me to a good beginner's primer. Most of them are like, oh yeah, well I took college courses and they don't really have beginners options outside of, I don't know, I guess they got introduced early enough, young enough. The ideas sunk in when they were still young and had malleable brains. I'm getting old. I need simple primers. I need things with pictures in them. We can even turn the animations back on. And VSync off. Oof. Okay. So we should have an airplane. And every few seconds, we should see the airplane message. Launch. Somewhere. Hopefully. Hopefully soon. I'm not seeing it. Disappointing. I'm not seeing any errors when we loaded scene 2. While that grinds away, I should see launch. I need to launch the airplane. Launch timer single shot true. Set the callback, set the duration, and tell it to start. Oh, I know why. Good heavens. I even thought this mentally to myself. Update. Do update. On update. There we go. This one. _, airplane launch timer update. The event just won't trigger if it's not in the update loop. I just read a mix of stuff for months. Haskell, Idris, Agda, Coke, Rust. Okay. The tools for imperative languages are bad for this. Eldris, Coke, and Agda are good, but they are functional languages. Okay. Haskell is a functional language as well. Okay, so there's an airplane, and it should launch off periodically. It thinks it's still running. Next launch in 13 seconds. if it's single shot, it should stop itself before the ding. That's my opinion. 13 seconds from now, is it gonna do it? Or it's just not gonna rerun again? All right, we can take a look at our big timer. Ding. If it has dinged, do that, do that. All right, we're gonna stop, then handle the ding. Otherwise, we have to handle the ding. Well, I guess this is more of a pause, reset kind of thing. This one never stops. Let's try that. The similar theory in imperative style is horror logic that's found in Ada Spark, as in CAR or only I could spell. Tony, good old Tony, right? Was he involved in Ada? No, this is a different. Tony, British computer scientist, foundational contributions, programming languages, algorithms, operating systems, formal verification. Okay, so maybe this is the same guy. He developed Quicksort. Or logic, is that what you're talking about? You can't do type-driven development. You don't get a proof assistant too, which is what good tools made for dependent types give you. Okay. Axiomatic basis for verifying program correctness. Okay. So just have a link I can follow there. Triple execution of a piece of code changes the state of the computation. Triple is of the form P and Q are assertions, and C is a command. P is the precondition, Q is the postcondition. Okay, so given the set of conditions, here's the command, here are all of the valid results. Executing the command establishes the postcondition. Assertions are formula in predicate logic. Inference rules, partial and total correctness, empty statement axiom schema. Skip statement does not change the state of the program. Assignment. Okay, so this looks like very simple logic stuff. Rule of composition. P, precondition, S, postcondition. QTR. Oh, I see. Okay. Yep, easy enough. Conditional rule, consequence rule, the while rule, for loop invariance rule, for total correctness. Oh gosh. Yeah, that starts blowing up pretty quickly. Interesting. Okay. Compilation finished. Okay, so we should see a launch in a few seconds, and then it should gracefully start the next big timer loop. Tell us how long it will be. Whoa! It says stop. Why? Oh God. Why on earth? Oh, pause, reset. Oh. Maybe just do the stop. guess we just do that. Well, at least I have a wiki link to some type theory stuff. It doesn't look too crazy. Type theory. Maybe there's like a list of things in Wikipedia. Lambda calculus. Okay, I've heard of lambda calculus. Didn't really dig in too deeply. I did look at the Y Combinator as an interesting little piece. I've forgotten it, but you know, intuitionistic type theory. Per Martin-Lof. Common one is theory, Kokan's calculus of inductive constructions. Oh my goodness. Proof assistance, programming languages, AGDA, linguistics, Montague grammar, social sciences. Double bind and logical levels are based on Russell's theory of types. Interesting. Type theory as logic. This is probably the one I'm most terms. Maybe if I just learned enough terms, I'd be able to understand better what people are saying in type theory. A lot of it's vocabulary, I think. Like, people are like, oh, here's the thing, and it's a monad. It's like, okay, but the formal definition doesn't help the layman understand what people are talking about. So that airplane should launch, and then relaunch, and then relaunch. Every 5 to 10 seconds, right? Launch again in 7 seconds. 4, 5, 6, 5, 2, 3, 4, 5, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6. Okay. I believe that plane will launch on a regular schedule. Okay. Anything else we need to do other than actually animate the sucker? Okay, so we get an action sequence. Action sequence. We'll use a 2-step action sequence. Sequence set immediate on the second action. Do the following things. Okay. Then we just need an animation. The only lesson you get from type theory for imperative coding is to use asserts, maybe type defs, to describe your meaning better. The tools are not good enough. Yeah, no, but they are better than nothing. I mean, a type def isn't the worst thing, although it's not strongly typed. Like, it doesn't separate. You can't inherit all the behaviors of an integer and not accept an integer from a type def, right? They don't do things you couldn't do yourself. It's just that dependent types are a way to automatically warn you if you have not done sufficient work on the variable to be able to use it in a function. Okay, that makes sense. So here's a variable. It's sort of the right type, but you have to make additional checks. Okay, assert. Okay, I think that makes sense. Using method. Interesting. We actually have some. We're just going to stick with linear for now. Easing method, linear. Airplane dots enabled equals true. One of the last things we do is turn it off. Set play animation. Step 0, play the animation. There you go. Set range from, let's just fly through our maiden voyage, left to right. We're going to start at airplane width off the screen. Renderer scale 100. Easy peasy. We're going to go from there to render frame width. We'll just apply flat. And how we apply that to this, given XY, and underscore airplane move to XY. All right. Double, double. Oh, comma. Okay. Search type defs. Okay, so we're going to enter the game, and periodically the plane should fly left to right. So it starts off on screen, and then it should launch. Whee! Bonk. 3, 4. There it goes again. Now, obviously, this is not done in any way, but it is very cute. Okay. That duration is way too long. It only take like half a second to fly across the whole room. We're gonna stick with linear for now. and enabled is false. So init elements, airplane, set the texture, and turn off the airplane. We don't render it at first. Now, the only piece missing, well, not the only piece missing, this one. We should play a sound here, maybe a whoosh. You know what, let's just get a whoosh. We have whooshes. They are already in use. Do I have a whoosh one? Solar strip. Whoosh one. Whoosh two? Or did I not spell it the same? Okay. Whoosh two. That shows up in multiple places. What about whoosh one? Game scene shows up here. Sandbox scene, sound warehouse. Yeah, so it's used one time. That's actually not bad. When we clear the guess. So when the airplane launches, we can use that for now as a filler. Get sound, play it. Play the animation. Okay. So the arc of an airplane should probably be linear transformation along the x-axis. We could describe it as the arc of a circle. That's another option, which would actually give us more heading information. Okay. Plane did indeed fly across. Okay. Here's one thing we want to do when we animate scene exit. We do want to stop that time. Underscore airplane launch timer stop. If it's running. Basically, we don't want the airplane to launch after we've clicked leave. Okay. What else do we need? We need to have a better animation. All right, several things we could do here. Okay, heading based on velocity. So we can get the airplane's current position, the position we want to move it to, calculate the velocity, and then set the angle of the airplane according to that. That's one option. So let's make it. Oops. Get 20-degree rotation. Can I remove the alpha? Like set the alpha for the airplane. I would feel a lot better if I could. Colors. Levels. I don't care. Whatever. I'm just going to start with the plane. Oh, probably move the layer. Move the layer. Just a scooch. Okay. Alright, so let's export this again. Airplane PNG. Okay. That should have an angle of 0. Let's see. The example they always give is the type vec n. The type depends on a variable, so it's called a dependent type. In practice, it's the same as a vec, but if you use a constant, they will generate a special function optimized for the constant value. You don't have to do it yourself, that's the value, but you could, and that's what we have done in C. Usually it's as simple as comparing a variable to a constant to know if you can use the special function or the general case version. Okay. So you optimize special cases and it can detect based on type which function to use. Okay. I suppose that makes sense. So when I set plane equal to 0, actually, let me fix one small alpha thing. I can actually fix the most of it pretty easily, I think. Or new layer, blah, whatever, nobody cares. We're just gonna use a paintbrush to do this. We're gonna color it white in that layer. Okay. Sorry, I'm just gonna remove some alpha. So the plane doesn't look so weird. There, that should look better. Now we export one more time and re-embed it. Export, re-embed all of our binary data. Type vec n. Type depends on a variable. Depends on n. Okay. We're going to re-embed our image data in our, rebuild our image warehouse. The creator of Idris said the performance is not always better despite having ideal information. My guess is they don't give enough low-level info to the compiler in the functional language, or they don't want to bend the program a little to make it use machine-friendly values in operations. Yeah, usually it seems to me that the type theorists are purists. They're ideologically driven, usually rather more than pragmatically performance-driven. While I think formal systems being able to tell you where in your system you've got mistakes or potential big problems is great, I think most type theorists are a little bit too far down the road for anybody to use it for practical purposes. Even though they have ideal information, they can't get the same performance, or they don't get better performance necessarily. I'm willing to trade some performance for a guarantee of correctness. Some. But I haven't really thought about how much I would be willing to give up. If you double your runtime size, so you're consuming even more memory, double is probably too much. I don't want to double the size of an executable. How much time performance would I be willing to sacrifice for guarantee of correctness? Kind of depends on the problem. Like certain types of like video game problems, for example, you kind of don't care about correctness. As long as you're within a percentage that's not visible, nobody cares. Okay, so that looks like a 0 angle reasonably well. It should fly by again. Perfect. You're still vulnerable to logic errors, as in feature or gameplay level errors. Yep, functional languages give you memory and timing safety. Right. Well, and yeah, functional languages give you guarantees. You can run formal proofs over functional languages because everything is immutable. You hand in a value, but it is not mutated ever. It is always returned as a new value, which causes other issues, which most functional languages understand. Sometimes you do need to maintain state. You can't have it be purely functional. There needs to be somewhere where you can store state for a significant portion of problems in the world, and the copies become too expensive. All right, so we're going to move from here to here. Well, let's do a couple things. Let's just have it descend to 200. Let's have it compute an angle to rotate. Float heading equals float x naught equals airplane dot position x and y, and delta x equals, if we're here and we're moving to here, it'll be x minus x naught dy equals y minus y naught. That gives me my velocity. I don't care about the magnitude, but I do care about the angle. So this is where I need a tan 2. Do I have math imported here? Nope. The state is on the stack in functional end. Right, but sometimes you need to maintain state across, well, for example, programming, like video games, right? There's a lot of state you need to carry from frame to frame that the stack doesn't handle well. C math. I think it's called ATAN2. I think that's what I want. But I've used so many things here. ATAN2. Compute arctangent with 2 parameters. And that'll be an angle. That'll be equals ATAN2, I think it's y then x, dy dx. Move to, oh, interesting. It would be nice if our airplane was centered, but we're going to rotate around the corner. It'll be fine for first approximation. Airplane.set rotation. Oh, rotate to. I'm pretty sure I did not convert that from degrees to things. Rotate to. Yeah. We are in radian world. So if we're flying straight across, our delta y is nothing. Our delta x will always change, so this is a safe operation given an airplane flight. But we can still, like, if dx not equal to 0, like if we haven't moved, there's no point in changing an angle. Let's just see how that goes. It may be counter-rotated. Well, it should be 0 because we're flying in a flat line. What I got from what I read is we should have good static analysis tools. Yes, and we should use general asserts as function parameters. Having those be checked while programming, not while running, and also dynamic constants, but it's better than what they do. I think you'll find that a lot of good game programmers use an awful lot of asserts. They don't do dynamic constants. They're on the same level as C and C++, just safer. Yeah, and it's practice. ATS is an imperative language with proofs as parameters. It's similar in spirit to what I wrote above. Still no dynamic constants. Okay, so you're trying to push it one beyond what anybody else is doing. I did not put the word do in. Okay. Interesting. So, with all of your type theory and working in with dynamic constants and formal proofs and such, what is your professional background? I guess education, probably computer science, if I were to guess. But like, are you like a... What do you do for your day job that you're into this kind of stuff for your hobby? Ooh. So it should just float across horizontally with no rotation. Soon. Yep. Okay. Now let's change the angle. An individual can always make the perfect program, but they don't make the compilers that everyone uses. Perfect program. In theory, I suppose that's true, but any program of sufficient size, and by size I don't necessarily mean like lines of code or even bytes of executable, I just mean like sufficiently complex, like real world problems, not toy theoretical problems. Any sufficiently sized program, it's going to become very, very difficult to make it perfect or prove it. You can't prove it perfect, at least not currently. Like you said, there's a lot of formal proofs, but and the bigger it gets, obviously, I don't know if it's exponential, but it's very difficult to prove. I can't tell if that angle is steep enough. Let's make that bigger. But it is certainly a worthy problem to tackle. That, I think, is the cool part. Whether you succeed or not, it's delving into something to try and make everybody's programming better. Static analysis tools are good. I make desktop tools in C#. Okay. I do not mind making some good desktop tools myself, but I usually go with Qt, more of a C++ based. I have a little company makes a desktop tool to solve electromagnetic high-power transmission line problems. Okay, it is rotated the wrong way, which is fine. That's easy to fix. Let's slow this down just so we can see better. There's always a nasty detail. You hear a great story about individuals and you realize it's also a tragic story. Their ideas and efforts don't transfer. Yep. However, so I still like the story of Donald Knuth. He cranks out, what was it, Tech? I think it was Tech, and he said, anyone who finds a bug, they'll get a check from me for $1, and then for 1 cent, 1 penny, and then the second bug will be 2 pennies, and then the third bug will be 4 pennies, and then 8 pennies. So it doubles every time, right? And so that's like an exponential. He bet exponential money that the bugs would fall off because he was that confident in his own ability to write it, right? And LaTeX is still used today based on his work. So, and I don't remember how big the checks ever got this year. New checks, which if you were smart, you did not cash that check. You kept it framed because there are not many people who have found bugs on Knuth's code. Knuth check bugs. I don't think it got very hard. Knuth reward check. Here we go. Here's a little light reading. That's a kind of guarantee and I guess confidence in yourself, right? So let's see here. Finding technical, typographical, or historical errors, or making substantial suggestions to his publication. Oh, I guess it's for his books. By March 2005, the total value of the check signed by Knuth was over $20,000. Very few of these checks were actually cashed, even the largest ones. More often, they have been framed and kept as bragging rights. Cute. Anyways, no, I think at some point he stopped sending real money, but still, kind of crazy that he had that kind of confidence, right? And if I sent out a thing saying, "Hey, find me corrections," I would not put an exponential growth curve on the number of problems that I found that are found in my work, right? And yeah. Okay, so let's see here. What am I doing? We changed the angle to be negative. So it should fly from here down. Nice. It should do that again. So maybe we should fly it up and see what it does. So we're going from that. So we start at the bottom left-hand corner. Are you on Linux? No. I am on Windows, but I always install like MingW, MSys, Cygwin, something. And then I run everything in Emacs, and including my bash shell, it runs inside of Emacs. So it looks very Linux-like when I'm working, but I am on Windows. But I've used Mac, I've used Linux, I've used Red Hat Linux, I've used Ubuntu Linux, I've used Yocto Linux, Raspberry Pi Linux. Oh, nice. So the angles are working out. Perfect. You can dedicate your life to an ideal like Stallman did. You can live in a hedonistic life. You choose which one, or you just end up in it? That is a good question. That is a philosophical question. And I guess it it depends on what you mean by just end up in it. I believe you are the product or the sum of a lot of choices, and anyone can make a choice to change their current situation. So people who are born in very difficult circumstances have chosen to elevate themselves out of those safe circumstances. I've seen people with horrific injuries become or debilitating physical setbacks become professional athletes, right? What was the swimmer not too long ago? Well, I'm getting old. The swimmer had asthma, right? Went on to become an Olympic champion, won tons of medals. But he would swim so hard in the pool that he would black out, right? How many people would say, "Oh, I'm a product of my nature. I was born with asthma, so I can't be a professional swimmer," right? It's too hard to be competitive with asthma. And he chose not to, right? Now, the easiest thing for humanity to do is to go with the flow, right? So, in that sense, the sum of your actions is to go along, to get what you got, to keep moving with what you've got. Don't change things, don't rock the boat. And that set of choices feels like you just end up in it, because it wasn't one big decision to, I'm going to overcome my asthma and become an Olympic quality swimmer. It was thousands and thousands of smaller choices. Events are a filter. If you describe the events, you know the person. Events are a filter. It's like programs with branches. Some die, some are refined by what happened in each branch. There's a different kind of person. Yeah, but are people deterministic? You can know somebody their whole life, and one day they will wake up and completely change everything. Whether that's tank their life, go sleep around, drink themselves into a coma when you didn't think they were that kind of person, or I've seen the flip, right? I've seen people who horrible lives, drugs and really nowhere to go, and they turned it around. So deterministic, but there's too many variables to predict the future. Okay, interesting. Do you have any children of your own? You don't know what you're going to think next. You don't know anything also. Yeah, so you're kind of a fatalist. Almost. No kids. Okay. If you have one kid, it's a very interesting experience. If you have more than one kid, you pretty quickly realize that each child is has a different personality regardless of what you try to do, right? The environments may be almost as identical as you can possibly make it, and those kids will vary from one another, even at very, very young ages with very few events in their what do you call it, the filter. I think there is some innate randomness variation, even twins, right? Even if you remove the genetic variation, kids are so different from one another that it kind of makes it hard to believe in a deterministic model for human behavior. Again, agreed. Too many variables to know for sure. And probabilistic analysis is probably the closest we get with human nature. Chaos theory, small things, big changes. Yep. Well, small variations in input yield large deviations the longer it runs. Right. Right. And if there's anything chaotic, it's human behavior. That's fair. So, if you decide tomorrow to get up and change and become a professional pianist, what was the set of conditions that would cause that? Could you identify it? Or if you just decided to go to Canada and sign up for the MAID program and get yourself ended? Some people I don't think could point at a reasonable set of events that would lead to drastic life-changing events. A lot of people can't. Again, the sum of many, many, many small actions involving the least energy. The people we celebrate, though, are the ones that go against the grain, make sweeping, huge, life-changing. Asking a human is a mistake. Yeah, but you can't really ask machines. They don't understand anything. They are less, well, humans lie, so that doesn't help. But asking a human is a mistake. Yeah, humans aren't good at understanding humans. I agree with that. That's not controversial, I don't think. So that to do is done. All we need now is to describe a reasonable arc. So if we make it a circle, let's say it's circle, we want the arc to be, what, 30-ish degrees from edge to edge? And the top of the plane to not go off the top of the screen. So maybe what we do then, you calculate something different. So instead of these positions, so let's compute these positions first. So float x naught equals y naught equals. No, I believe in human free will. I think there is more to humans than a chemical computer. You know from reason alone that decisions are not normal, are caused because thresholds were reached. The person was certain enough that their current path was not going to be satisfying enough, so the value cost bet was better in changing direction. Yes, but that's not the question, right? What was the difference between that person and the person right next to them who did not choose to make the same decision? You know, multiple people all in the same drug house. One person gets clean, one person doesn't. Again, too many variables to really control for, but I also think there's more to it than just how many variables do you know? Oh, you're asking what the inputs are. There's too many inputs, right? It's your whole history. What did your parents teach you? What did you learn in school? What were your friends like? Did they help and teach you? Did you see somebody else crawl out of the pit? Did you see somebody else achieve greatness? Did you see someone else falter and die? Like, yeah, it's your whole history, but not all of them leave conscious imprints. So even asking somebody what were the reasons you did this doesn't give you a reasonable set of inputs for why they did a thing, right? What's the biggest prime number? Yeah, there's no answer. They just keep getting bigger. The reason people do things is often subconscious. Like they can't articulate why, most people. Which, again, I think is that why did you... Where is it? You just ended up there, right? Sum of lots and lots of decisions. What's the biggest prime number? Well, it's certainly not the Mersenne prime. Oh, what am I doing here? Oh, we don't want these. What am I saying? What am I saying? We want a pivot. Pivot x equals frame width divided by 2. Pivot y equals regular frame height times 2, or that'll put us one full screen below our screen. And then our angle, I think 0 is here. So we want to be minus something to, let's see here. Angle 0 equals minus, not pi, let's see here. Global pi, is that what I called it? Capital P, lowercase p, lowercase p. Pi over 4. Let's see here. So we want to go from 90, which is pi over 2. So we actually want like 3 pi over 4 to pi over 4. We'll try that. Angle 1. Okay. This time, we're going to go from angle 0 to angle 1. Angle A. Our current x, our next x, we need to calculate. So float x1 equals sine of angle, sine of A, y1 equals sine of cosine of A, sine of A. Compute those. And then move to x1, y1. Let's just see what happens. Oh, let's see here. The only human thing to do in front of an undecidable problem is to be humble. And be humble all the time. There's too many things you don't know. That is for sure. The sum of human knowledge is vast, and even that doesn't really cover everything. Never mind what you can actually learn of that. I wanted to be the best when I was a kid, better than my brothers at games, etc. You hit reality. Kids are younger than you being much better. That's a similar problem. Of course, it would be fun to be the best. Someone like you would love to be the best. Yeah. If you're really that person, you know what sacrifices were necessary. There's no free lunch. Irony is everywhere. Yeah, no, it's like I tell people, hey, I would love to be a good artist, but I never put in the time. I couldn't. Like I just can't. I haven't prioritized it. I know what it would take. I could get in good shape. I've done it before. I know how. But I know what it would take, and it's not what I do, right? Or, you know, in some cases, I don't even know what it would take. There are things that I would love to be good at, and I'm like, I don't even know where to start. But that does not mean that you have to be fatalistically down about the whole thing, right? It's you can be better than you were yesterday. That's always a valuable skill. To say I'm tired of being where I am. I want to be somewhere else, and here's what I'm going to start. Even if you don't know what it's going to take. When was it? Back in May? Well, back in April, I had a job that was rather stressful for me. The last 6 years have been stressful, not just that job, but other things. And so I quit that job, and I've lost 55 pounds. I can run, I can do pull-ups again, like all the things that I was destroying my body trying to be good at something. And now I'm repairing that damage, right? I'm better than I was yesterday. Believing there's nowhere free will has, from my conscious mind, no impact or conclusion about reality. Well, and here's another thought. People claim that they don't believe in free will. But that's words. What do their actions reveal about their beliefs? Okay, well that is not rotating at all where I thought it was going to be. That is very cute though. In practice, it's like, I don't believe there's no free will. Yeah. Oh, people are like, oh, I don't believe in free will. We're all just chemical processes. It's like, yeah, but you act as though your choices have consequences that you can choose. So, even people who claim they don't believe in it don't live like it. And a revealed preference or belief is always more accurate than the stated belief. Okay, that rotation was wrong. Oh, pivot. You didn't add the pivot. We also need a radius. Why don't we have a radius? Float radius equals. So if we're one screen below, we need to be more than one frame height above. Like maybe like times 1.75. That should put us near the top of the screen at the peak of the arc. Angle. Pivot. I'm not passing in the pivot at all. Float. Pivot x. Oh, not that. What am I doing? I just need to capture it. Pivot x. Pivot y. And a radius. X is pivot x plus radius times cosine of angle. Pivot y plus, it might be minus. In fact, it probably is minus. Because I don't choose if I believe in it or not, and there's no conclusion you can get from it. I think it's a nerdy question. There's a cause that made you question the purpose of life. That's the real situation and problem you're facing. Well, and sometimes, so in my case, I've never really questioned that much about it, but it was an interesting thought experiment when somebody else brought it up, right? Trying to think. Like, I know I'd heard it before, but Sam What's-It and Peter Peterson arguing the existence of free will was one of the early ones I remember. It wasn't the first time I'd heard of that debate. So it was more for me a curiosity than an existential crisis that needed answering. Where's this airplane? That's not terrible. I've seen worse. Cool. The whoosh starts too soon. The duration is too long. It's not fast enough. We just need to narrow this range down a bit. So instead of 3/4, let's go with like 2.5. We basically just want to start and end on the edges of the screen, not have as much white space time at the end. Plane looks good. Yeah, that last arc was pretty encouraging. That felt better. That felt good. And it's on a timer, so we'll just keep launching over and over again. We can make that launch a lot faster just so we can see more repetitions. Okay, timer is starting. Should be somewhere in a few seconds here. Not bad. Although I'm not sure if where's the on ramp here? Nope, it's starting here. So we do have to increase that angle out. Can't start there. Oh, let's see. Let's change the start time. Let's make it quicker so I don't have to wait so long. 5 to 10 for debug purposes. It's still running. All right. Okay. Launch it. We may pull all the airplane code out into its own little thing. 3, 4, 5, 6, 7. There we go. Now, does it disappear all the way off the edge? Looks good. Is it starting off the edge-ish? Oh. One thing. We're not really rotating around the right point anyways. Init elements. We're going to center the plane. I forget what that's called already. Underscore. Oh. View layout. Where's my airplane? Get the width, the height, underscore airplane. We need to center it so it rotates about the center. So we set center. Which should be width over 2, height over 2. So it should rotate about the center of the image. Now randomly in your game, it should just launch an airplane every random variable. Random range. We're gonna have to start wrapping up soon though. I have a thing to go to at 7. I gotta do a little prep for. Try to get some dinner in before I run. But let's watch this airplane. Is it off the screen? Does the rotation look better? Okay, so it launched up here, which is fine. Maybe we slow down the airplane so I can see better. Duration. Let's go with the 3-second duration. There's someone on the OS dev forum. He's been writing for NOS for 10 years, I think. He says he wants to make it the perfect before releasing it. He thinks a YouTube video will be enough to convince everyone that they should use it, even despite all the costs of switching. Basic idea is to combine computers and seamlessly work with other person You should rewrite the tools to integrate well with the system features. I have not read more, but I already am not convinced it's something I would like. No, the cost of switching is brutal. Like, I'm still using Emacs. It's not the best editor, but the cost for me to edit is prohibitive. Random starting point and direction of travel. JTL, that is on my plan. For now, I'm just trying to make sure that the arc actively goes from edge to edge. We should probably make that timer a lot less so we can watch it repeatedly. No, yeah, we'll have some random offsets and heights. That is a good idea. Thump. Okay. So we're gonna probably hold that there. Is that true? Is that true? Are we ready? We could start adding those random heights. We could also make this a lot less so that we don't have to wait. Okay, so this pivot, we are halfway into the frame. I think we're going to keep that there. So the apex of the arc is at the center of the screen. Pivot Y. This we can change. So we can maybe do something like _URNG next F. I don't remember what it's called. Uniform RNG header next float. Okay. We'll be between, I don't know, maybe like 1.5 and 2.25. 2.25 radius would depend a little bit on this thing. And looks for URNG dot next float 1.75, 1.25 to 1.75. I don't know, maybe angle. And maybe what we should do is take both of the extremes of pivot and radius and just make sure that it appears within bounds. So we can test that tomorrow. I'm not going to do it today. X, Y, the duration can be a random thing. Next float. In this case, we're not going to vary it that much, but we can stub it in 3.25. Because we do want to watch and make sure that it's coming on and off the screen reasonably. Set duration, set using method. Blah, blah, blah. X angle. We shouldn't need to vary the angle much, maybe. There's the latency problem, as others have said. There's always criticism because we want different things. You could make the perfect machine for one thing if you have enough resources. We use vector registers for floats, wasting like 75% of their size because we like simple code. Yep, it's true. I don't think most modern programmers have any conception of just how fast our computers are. When I talk to a web dev and they're like, well, we've got 50 milliseconds, or we've got 100 milliseconds to respond. It's like, but why? Why is it? That's nice and low. That's still very low. Maybe we shouldn't. Oh, there we go. So it is varying. Woo! Oh, that's off the top. Oh, but not far off the top, so that's good. Whee! There you go, random airplanes. We should also do a right-left flip-flop. Easy peasy. It's still going. No. I'll think about that in a minute. So let's see. We have some live sense to do. Let's just write stuff in the journal. Doodad flying airplane. Start a flying airplane. Doodad for flying airplane is Looking okay. Need to establish bounds for random ranges that look appealing. Need better airplane image. Need better sound, maybe. Separate into its own class to not clutter game scene. Needs refinement. That doesn't look right to my eyes right now, but that's probably because it's been staring at the screen for too long. I don't know, maybe we need a better sound. Maybe we don't. Separate into its own thing. Okay, so we have a doodad. 100 milliseconds means the page will appear instantly from the POV of the user, assuming he has a fried brain or just wants to read articles and chill. Nope. Because that 100 milliseconds is what every web developer uses to justify how long it takes them to respond, not the full page load time. Right? We can transmit a gigabit of data. We can do file reads of gigabyte per second, right, off of a magnetic platter hard disk. So why does it take me 5 or 10 seconds to load a web page? It's because they've broken it down into horrible units of data transfers. It's all uncompressed. It's JSON objects mostly, which is text, which is the terrible way to transfer your data, even with compression, which then has to be interpreted at both ends and escaped, unless it's XML, in which case it's even worse. And they think that means that their unit, your API call to their response, has a 50-second requirement, not the whole page. If they batched up the requests, responded reasonably with a compact data format that was not so verbose, you could have the internet running so much faster and more energy efficient. But you try to explain we should not use APIs, just download the product and use it locally. Yes, I would much rather run everything on my machine. Exactly. Yeah, I would rather run a desktop application. Yep, I agree with you. And microservices and serverless does not mean what you think it means. And codeless programming, oh my gosh. So many bad movements. Hopefully they'll die. But the internet's too useful, and it's too useful for people who don't know and don't care. So I doubt it'll improve. If it has a huge database, it probably user data and info don't need those. Well, but your desktop application can still access, make requests to that database. It doesn't have to go through a web page, running inside of a browser, inside of an emulated virtual machine, running a scripting language that's even if you have to access that database, it would be more efficient if you did it on your desktop. You have no control over anything in the browser. Yeah, exactly. Yep, I agree. All right, let's see. Oh, hey, I guess I have not plugged for a while my Discord channel server thing. So let me just throw that down. I've got to get running soon, but feel free to drop in the Discord. It'll let you know when I'm streaming. It's not that active a server, so you won't get spammed, but once a day or so, it'll be like, hey, I'm streaming. Even though we're not like 100% aligned on interests, I think there's enough overlap. It could be interesting. Yeah, I'm going to try and wrap up this video game in the next couple of months and then see where we go. So thanks for joining. Thanks for all the chats. Thanks for the conversation. Always welcome. Always happy to do something besides stream of consciousness coding. Yep, have a good night. See you later. Bye, and see you tomorrow.